Alright, in this video I'm going to talk about the relationship between the core and equilibrium that is presented in chapter 18 of Musgrave Winston Green, and that is going to be our last topic for general equilibrium theory. So after starting this topic, we discussed some applications of general equilibrium, so no more theory about equilibrium, and we finally move on to second part of the course, and we are going to study mechanism design theory. So before introducing the new topic, let me go over our previous studies of general equilibrium. So, because now we are dealing with the last topic. It's a perfect time to go over our previous studies of general equilibrium. So we started making assumptions on the preference relation. So preference relation has to be rational, so complete and transitive, and furthermore, it has to be continuous, right? In such a case, there exists a nice utility function that represents one consumer's preference over commodities. So using that utility function, we can formulate utility maximization problem from which we can derive demand function using uh, Lagrangian multiply method, right? That is actually what we have studied in chapter 3. So when we have studied consumer theory and consumption behavior in the first sequence of microeconomics. Now going to chapter 16, so going to equilibrium framework. So we have many consumers and we have many firms existing in an economy, right? And then in chapter 16, we established two welfare properties of Wallachian equilibrium. So for the first welfare theorem, we had to impose one more condition on preference relation, that is a strong monotonicity, or a little bit weaker assumption, local non-satiation. Okay? If either condition is met, then we know by virtue of the first welfare theorem, every Wallachian equilibrium allocation is Pareto efficient. Right? And then due to the relationship between Pareto efficiency and social maximization, so social welfare maximization problem, we can say like every Wallachian equilibrium allocation is socially desirable, okay? Because it maximizes social welfare function. Okay? Almost equivalent between, we have almost equivalence between Pareto efficiency and social welfare maximization. Okay? And for the second welfare theorem, we had to impose one more condition on preference relation, that is a strict convexity. So preference is strictly convex, so the utility function is strictly quasi-concave, then we can say any Pareto efficient allocation, so any socially desirable allocation can be achieved in market mechanism, right? So there exists a price factor supporting that desirable allocation as a market equilibrium after redistribution of wealth, right? And moving forward to chapter 17, so maintaining assumptions on the preferences. So we make total five assumptions on the preference relation. We derive several properties of excess demand function. So by that, we can characterize Wallachian equilibrium in just a one line of equation. So z of p is equal to 0. Okay? So the solution, so Wallachian equilibrium price factor can be characterized by a solution to this equation. And we know several properties of excess demand function. And one of them says z function is homogeneous of degree 0. So if p is a Wallachian equilibrium price factor, any linearly proportional price factor p, so alpha times p, will be Wallachian equilibrium as well. We also examined under which condition this equation has a solution, so existence of Wallachian equilibrium. As a matter of fact, we don't have to impose any other conditions on the primitives. So Wallachian equilibrium exists in a fairly general environment. But for uniqueness of equilibrium, we have to impose either Verb, so weak axiom related to preference or the growth substitute property. Okay. If either condition is satisfied, then we can say Coalitional equilibrium is uniquely determined, so there is no other equilibrium. Right? We also examine the stability of equilibrium. So under either verb or the GS property, the same condition for the uniqueness, we can say no matter where initial price is firmed, so no matter where initial price is set, you know, over time, that price adjustment process will lead us to the unique comparative equilibrium, unique Coalitional equilibrium price, right? We examined such a stability of equilibrium in the previous video. So, in fact, we studied many things about general equilibrium, okay? But there is a one thing we missed so far. That is, I highlighted these two assumptions several times when I talked about first welfare or second welfare theorem. These are the, price mechanism. So there are two presumptions about uh, the market mechanism, market completeness and price-taking behavior, right? So the market mechanism based on two assumptions. First, market completeness, completeness, okay, and the price-taking behavior, okay. So far, our studies of general equilibrium are based on these two assumptions. So market completeness requires that every commodity should be priced. So there exists a unique price for each commodity. Okay? And I explained some examples where this condition is violated, especially in the presence of externality. So in case of public goods such as a national park, air, or national defense, we have some benefit from those public good, but it's very difficult to think about its price. It's very think about its property right. So it's very difficult to think about its price, right? So market completeness assumption will be violated in the presence of externality. And the second assumption is much more important, price-taking behavior. So that requires price is solely determined by aggregate demand and aggregate supply. Okay, so if we think about this assumption a little bit more, so the market mechanism allows each consumer to choose one bundle that maximizes his own utility at the given price, right? So from that, at the given price, we can tell how many units consumers are willing to purchase. That is a demand function, aggregate demand function. Similarly, on the firm side, so supply side, market allows at the given price how many firms. So the market allows the firms to choose one production plan that maximizes its own profit, right? So we can derive a supply function that tells us at the given price how many units will be supplied, so produced and supplied to the market. Okay, and then the equilibrium market price will be determined at the point where demand and supply are exactly offset, exactly balanced off. Right, so that is a how the market mechanism works. So based on these two assumptions and under this special mechanism, very specific mechanism, we could derive socially desirable allocation. So that is Coalitional equilibrium allocation. And there exists the equilibrium price system supporting that allocation as a market equilibrium. All right. Now let me introduce the last topic. In our study of general equilibrium. So one natural question that arises is, you know, do we have to rely on these two assumptions, market completeness and price-taking behavior? Or, do we have to rely on market mechanism in order to achieve this socially desirable allocation? Right? Is there any other mechanism where we can achieve socially desirable allocation, right? Or can you achieve this socially desirable allocation without making these two assumptions, right? Surprisingly, this question has been first casted by Edgeworth long time ago. So in his inflation book, written in 1881, so a long time ago, he has casted this question in his book. And his answer to this question is no. We don't have to rely on market mechanism. We don't need market completeness and price-taking behavior assumptions. As long as there are many competitors, so we can anticipate a high level of interaction between them. So as the size of the economy grows up, so grows large enough, you know, a price system forms, comparative price system forms. And as a result, Coalitional Equilibrium, so socially desirable outcome, emerges. All right? And we have a similar logic when we studied intermediate microeconomics. So, think about competition between firms. Okay. Maybe initial market price is higher than marginal cost. So the existing firms make a profit. Then, some other potential entrants will enter the market to realize that high profit. Okay. But as more and more firms enter the market price starts decreasing, right? So it will be heading toward a marginal cost. So, because we can anticipate more and more firms will enter the market up to the point that market price reaches the marginal cost. If the market price is below the marginal cost, then the firm now makes a loss. So then, existing firms will exit the market. So so in the end, the price will be comparative price. Okay, so at that price, demand and supply will be, so the people are, people are purchasing units at that price, and the firms are supplying the units at the given price. Then the allocation resources, so the supply and demand are, working efficiently. So the allocation is efficient, so part efficient, so socially desirable. Okay, but even that story is also based on some specific mechanism. Firms compete in a market, given market mechanism, right? That is based on market mechanism, right? But surprisingly, yeah. So this idea of interaction, in the end, lead us to socially desirable allocation through a formation of comparative price system. That idea has been proposed by Edgeworth and established into theory by Debord and Scarf in 1963. Uh, so in that theory, in that theory, we don't need any specific trading mechanism. So this result is independent of a trading mechanism where interactions occur. All right. So interaction alone, as long as so interaction in a large economy alone leads us to socially desirable outcome. That is the main result in chapter 18. That is a main objective. So there is a main topic in we are going to study in this video. Okay. Interaction brings us socially desirable outcome. Okay. Then the question is how to describe interaction between economic agents, right? So now we are going to borrow some tool from cooperative game theory in order to describe this interaction. Okay. That is the core. Okay. So we are going to study the relationship between core and equilibrium. So when the size of economy is small, so when there are small number of consumers and small number of firms, then there will be some gap between core and equilibrium. But as the economy grows large enough, this core, so that is the outcome, that can be thought of as the outcome allocation from this interaction between players, between economic agents, will converge to socially desirable outcome, equilibrium. Okay, so these results provide us micro foundation for price taking behaviors. Because interaction alone without the aid of price system. So we don't have to rely on market mechanism. We don't have to rely on market completeness assumption. We don't have to rely on price taking behavior. Interaction alone gives us socially desirable outcome. All right. So with that picture in mind, let me introduce the core. Okay. So the core is a solution concept that has its foundation in cooperative game theory. And before introducing this core and cooperative game theory and the distinction between cooperative and non-cooperative theory, let me first illustrate the framework. So for simple exposition, I'm going to narrow down the scope of the model to a pure exchange framework. Okay, so there's a no production, there are just I consumers, and they are inherited some endowment from, say, their parents, and they have consumption set, possible, so the set of possible bundles, and their innate preference relation. So these are, three components of pure exchange economy. Okay, and then we maintain the assumption that preference relation is strictly convex and strongly monotone. And with a slight abuse of notation, let me use capital letter I to denote the set of consumers, and at the same time to denote number of consumers. Okay, so I is the set of consumers and the number of consumers. So the cardinality of this set. Okay, and here is one important concept to illustrate the core, to define the core. There's a correlation. But definition is really simple. So the correlation is defined as any non-empty subset S of this set, the set of consumers. Okay, so if we have just the two consumers, so set I is 1 and 2, then there are total of three possible correlations. 1, 2, so each consumer now acts individually, do not make some joint correlation. Okay, and then 1 and 2. So we have three possible correlations. Once again, not empty set is not counted as a correlation. Okay, and in case of three consumers, we have total 7 possible correlations. Each individual working individually, and 1 and 2 make a correlation, and 1 and 3 make a correlation, and 2 and 3 make a correlation, and there is a grand correlation. So every individual joins this club, joins this correlation. Okay, so the set I, so the set of whole consumers, if they make a correlation, we say it's a grand correlation. Okay. So with that in mind, so with that definition, now let me illustrate cooperative game theory. So when you study the first sequence of microeconomics, I guess you've studied game theory, or if you took elementary game theory class, then you studied so you have seen some games, strategic interaction between players. In non-cooperative game, that is it. So the material in elementary game theory or the first sequence of microeconomics deal with non-cooperative game theory. So in non-cooperative theory, games are put in normal form or extensive form. Normal form looks like this. So if players have a just finite number of actions or strategies, think about a prisoner's dilemma. So two players can choose between cooperate or and defect, and the payoff are, say, 2 and 2, and 3 and 0, and 0 and 3, and 1 and 1. Okay? So This is a very standard example of a prisoner's dilemma. That is called the normal form game. Okay. So in the normal form game, we have to specify. So we have to specify how many players and how many actions each player can choose, and what is the payoff to each profile of strategies. So if two players decide to cooperate, what is the payoff of player one and two? Okay, and there is another exposition. So there is another way to, uh, define the game. There's extensive form. Okay, so you may have seen this kind of game tree. So player one first choose between, say, A and B, and player two, after observing player one's choice, or without observing one's choice, choose between C and D. Okay, like this one. So so these two are kind of two building blocks in non-cooperative game theory. All right. Now, the central solution concept in non-cooperative theory is Nash equilibrium. Okay. So in Nash equilibrium, we assume each player makes a decision so as to maximize their own utility. So in this normal form game, player one will choose one of these two actions that maximizes his utility. So does player two. Okay, so that is kind of consistent with Wallachian equilibrium. Okay, that is the concept of equilibrium. Each player behaves for their own interest. Okay, so there might be some conflict between their choice whenever they move differently. Say, think about the relationship between buyer and seller. Seller would like to increase the price, so transaction price. On the other hand, buyer is willing to decrease the price, transaction price, right? So there is some conflict. They want to move differently, right? And what is a equilibrium if we have two, countervailing incentives? So two opposite incentives. Okay. So the non-cooperative game theory can be thought of as the study of, interactive conflict, or, so some strategic interaction, right? So the main solution concept in non-cooperative one is a Nash equilibrium. So that is kind of consistent with the Wallachian equilibrium. Because even in Wallachian equilibrium, we allow firm and consumer to choose one action individually for their own interest. Firm for their accounting profit, and consumer for their utility. And likewise, in game theory, non-cooperative game theory, each player will choose their action individually for their own interest. Okay? But cooperative game theory is quite different in that sense. As its name suggests, cooperative game theory focuses on players' cooperation motive, cooperation incentive. So the way to put the game is quite different. That is a neither normal form, neither extensive form. It is called coalitional form or characteristic form. Okay? So standard cooperative game looks like this. Suppose that we have three players, one, two, three. Okay? Then the game is given by one function, say v, okay, which is called characteristic function. Characteristic function, okay, which is a mapping from possible coalition to real number. Okay, so for example, let me come up with a one example. We have 1, 2, 3. Okay, for this coalition, so this grand coalition, v function takes a value of 10. Okay, and it stands for the worth of this coalition. So V function gives us, so this is the worth of or value of coalition 1, 2, 3. Okay. So if these three members make a grand coalition, they can make a surplus of 10. All right. Interpretation is like this. If player 1 and 2 make a coalition, so let me say the value is 9. So player 1 and 2, if they make a team, if they make a coalition, then they can make a surplus of 9. Say 2 and 3, they can make, say, 6. Okay. And 1 and 3 make 4. Okay. And let me say, if each individual acts individually, say player 1, if he does not make a coalition, if he is not involved in a coalition, acting individually, can make surplus of 4, V of 2, 3, and V of 3 is 2. Okay, so that is a one complete description of one possible cooperative game. Okay, that is quite different from, the games in non-cooperative game theory, right? In non-cooperative game theory, because we assume each individual acts individually for their own interest. So we have to specify strategies, we have to specify, the payoff for each strategy profile. So in both firms, in normal firms and even in extensive firm. Okay, but in cooperative game, there's a no strategy. We just focus on each individuals to make a coalition. How do they cooperate each other? All right. So for player 1, if he acts individually, he can make a surplus of 4. But if he make a team with player 2, then the surplus increases to 9. Okay. So 1 and 2, if 2 plays alone, can make a surplus of 3. But by making a team with player 1, surplus now increases to 9. So 1 and 2 clearly have an incentive to cooperate. Yeah, like 2 and 3. And 1 and 3, if they make a team, they will be worse off, right? So they have no incentive to cooperate, right? So study of cooperative incentive is the main objective of cooperative game theory, all right? So as a matter of fact, from my point of view, there is a no clear boundary, so there is a no clear borderline between cooperative and non-cooperative theory, because even non-cooperative theory, we examine such a coalitional motive. Think about a criminal competition. So, say two firms compete with each other, compete each other with quantities. So in the same market. So suppose the market price is given by A minus B, Q1 plus Q2. And two firms compete each other, by choosing quantity. Firm 1 chooses Q1, 2 chooses Q2, right? And the way to find the Nash equilibrium is we first formulate the profit, each firm's profit, and from the first of the condition, we can derive each firm's best response. So yeah, let me skip the details, but if we put Q1 here and Q2 here, and this is BR1, from 1's best response to from 2's choice of quantity, and BR2, that is a function of Q1. And Nash equilibrium will be determined at the intersection between the two best responses. And so that is a one elementary topic in industrial organization, or game theory, but you may have seen this kind of logic. So if these two firms make a coalition, make a cartel, okay, and then each firm produces less than equilibrium quantity. Equilibrium quantity was here, Q1 star and Q2 star. But now, instead of choosing this equilibrium quantity, they make a cartel, right? And then choosing some quantity less than equilibrium one. So just like, acting as a monopolist, they merge each other, so make a monopoly, then they can enjoy some monopolistic profit. That will be higher than this equilibrium profit. But we have studied that this kind of cartel is not sustainable because if firm 2 chooses this quantity, then, although initially they agreed on this quantity, if firm 2, if firm 2 produces this quantity, then firm 1 now has an incentive to increase the quantity. So leaning on the first agreement, then, increase in quantity to make a higher profit, right? So for this reason, this cartel between two firms, even in simple kernel competition, is not sustainable. Okay, so in even in non-cooperative game theory, we also studied such a cooperation motive. But the key difference is, in non-cooperative game theory, so in kernel competition, if we have a coalition, that has to be self-enforcing, meaning that each player, so each firm has an incentive to join this coalition. So by acting unilaterally, each firm has an incentive, so finds it profitable to join this club, to make this cartel. All right. So it is not binding contract. So it is a not binding agreement. All right. They just meet each other at the outset before choosing quantity, and then they can talk to each other and agreeing on some, this kind of quantity. But this is a not binding agreement. There is a no, so that agreement is not legally enforced by anything. Okay, but in cooperative game theory, if player one and two agreed to make a coalition, okay, then player two in that case cannot make a coalition with player three. Okay, that is a binding contract, binding agreement, binding coalition. Okay, so the cooperative game theory allows for such a binding agreement, but non-cooperative game theory, does not allow for such a binding contract, right? So that is a one major difference between cooperative and non-cooperative game theory. So in cooperative game theory, we allow for some effective negotiation between players, and then they can make binding agreement. So allows players to bind themselves to any advantageous agreement. Right? That is a main distinction between cooperative and non-cooperative theory. All right. So with this background in hand, now let me examine. Now let me examine this example. So now let me work with this example. So here we have seven possible coalitions. Now let me ask, which coalition is sustainable? I think about this grand coalition, all right? And examine if that coalition is sustainable, all right? So three players can make a surplus of 10, all right? Then after making this coalition, so after making this surplus, these three players have to decide on how to divide this surplus 10, okay? Then suppose that, so x1 is a share of player 1, x2, share of player 2, share of player 3. All right. For this correlation to be sustainable, first x3 should be larger than 2 in this correlation. Otherwise, player 3 will not join this correlation because by acting individually, he can make himself a surplus of 2. Right? So x3 has to be larger than 2. So that means x1 plus x2. So the sum of the first two players' shares cannot exceed 8. Right? But in this case, the two players, 1 and 2, will not join this club, will not, join this coalition because by making a separate team between these two players, they can enjoy a higher surplus, right? So for this reason, this grand coalition is not sustainable. What about 1 and 3? So 1 and 3, that is the worst coalition because a player 1, by acting individually even, he can make the same surplus. So there is a no way for, so there is a no chance that player 1 and 3 make a team. What about this one, 2 and 3? Okay. If we apply the same logic to this one, so, player 3 has to be x3 should be larger than 2. Meaning that x2 will be lower than 4. Okay? But, for player 2, from his perspective, if we join this coalition 1 and 2, make a team with player 1, right? So player 1 may yield, say, half of 9, 4.5 to player 2. And player 2 will be more interested in, making a correlation with player 1. So for this reason, this is not sustainable either. So the only sustainable correlation is this one. This one. 1 and 2. Right? So 1 and 2. And player 3 will be acting individually. Alright, so the payoff or the allocation is going to be, so x3 is going to be 2, right? And x1 and x2, player 1 and 2's payoff is going to be, so x1 plus x2 is equal to 9, but x1 should be larger than 4, right? Otherwise, player 1 will not make a team with player 2. And x2 should be larger than 3, right? So as long as, should be larger than 4, I guess. Otherwise, if x2 is smaller than 4, now player 2 will make a team with player 3, right? So should be larger than 4. So any allocation x1 and x2 satisfying these three conditions can be sustainable. So it can be sustained in this cooperative game, right? So we have this one, allocation for player 3, and x1 and x2 are this. So say 4.5 and 4.5 can be sustained, right? So by examining these issues, we can examine each player's cooperative incentive. Player 1 and 2, so for player 1 and 2, the cooperative motive, so the incentive to make a team is the highest, right? Okay, so now let me define the core with this correlation. Okay, so correlation S, we say correlation S improves upon or blocks a feasible allocation X. So because now we have I consumers, so allocation, so the payoff or allocation or consumption bundle for for consumer 1 and consumer 2 and respectively, and so on. So if coalition S improves upon blocks of feasible allocation X, if there exists another allocation X tilde inside the coalition S, okay, so by making this coalition S, okay, we say this coalition blocks the feasible allocation X. If there exists a better allocation X tilde inside the coalition S, such that for every member in that coalition S, so every member in that coalition weakly prefers allocation X tilde to X. Okay, and furthermore, at least one member in that coalition strictly prefer X tilde to X. Okay, so that is a very analogous to parity efficiency. Okay, so it should parity improve. So X tilde should parity improve upon the allocation X. And the second condition is a feasibility condition. So that allocation X tilde, better allocation, okay, must be feasible inside the coalition, meaning that the aggregate demand, so the aggregate bundle inside that coalition. So if we add up, so if we do sum over X tilde, okay, so aggregate demand inside the coalition should be equal to total endowment inside the coalition. Okay, so should be feasible. All right. So if there exists such an allocation X tilde inside the coalition, then we say coalition S improves upon or blocks the feasible allocation X. So that will be dominated by X tilde, and X tilde is feasible by making coalition S. Okay? And we say that allocation X has the core property if there's a no correlation. So if there's a no correlation S improving upon allocation X. Okay, so there's a no correlation that blocks allocation X. Then we say allocation X has the core property. Okay, and the core is defined as the set of allocations that have the core property. All right, so in order to enhance the understanding about the core, let me go back to this example. So say, say, say x2 is a 3.5 and x3 is 2.5 and x1 is 4. This is not this is not an element of the core. So this allocation does not have the core property because this allocation corresponds to the situation that 2 and 3 makes a team. Okay, and then they divided this surplus into this way. So 2 has a 3.5 and 3 has a 2.5. And then player 1 is acting individually. It cannot be sustained. So it does not have the core property because there is another correlation. So there is a correlation S 1 and 2 and 3. Okay, this correlation. So 1 and 2. So correlation 1 and 2. So correlation is just one subset of the total individuals, total consumers. So there is a correlation S. Improves upon this correlation or this allocation. Right? So here X tilde. So X1 tilde is 4.5. X2 tilde is 4.5. Okay? This allocation is feasible inside this coalition because by making a team, they can make a total surplus of 9. Okay? And then two members in the coalition, strictly prefers X tilde to X, the previous coalition, of the previous allocation. Okay, so now this allocation will be blocked by coalition S. so does not have the core property. Okay, but allocation satisfying these three conditions, and x3 is given by 2, it has the core property. Because there is no other feasible allocation that improve upon this allocation. All right, so that is the core. So that is a one central solution concept in cooperative game theory, right? Another solution concept is a Shapley value. I'm not going to illustrate that in this video. If you wonder about another solution concept, you may refer to the appendix of Musgrave and Green, chapter 18. And it gives a very short and comprehensive review about the cooperative game theory. All right. Then let me just compare with a parity efficiency. So parity allocation X is parity as I told you, there is a much similarity between core and parity efficiency. But in parity efficiency, we do not consider every possible correlation. We just consider grand correlation. So if the allocation X is not blocked by grand correlation, then we say allocation X is parity efficient. Okay, so for the core, we consider every possible correlation. For X allocation X to be the element of the core, there is a no correlation S, so every possible subset of I that blocks the allocation. Okay, so comparing with the parity efficient allocation, the core is a subset. Okay, so core. So set C that denotes the core is the subset of parity efficient allocation. Okay, because for parity efficiency we have just one condition. It should not be blocked by grand correlation. But for the core we have several conditions. Should not be blocked by every possible correlation. So because we impose more conditions on the core, so core is a subset of parity efficient allocation. All right, but uh, in case of two players, so in case of two consumers, so now we have an Edgeworth box right here. Okay, then core is going to be the same as contract curve. The contract curve was defined as the one portion of Pareto set between the two indifference curves passing through the initial allocation. Right? That is the core because for individual one, for individual one, for individual one to make up to have an incentive to make a correlation with a consumer two, right? The allocation must be here because otherwise if the allocation was right here, say below this contract curve, say here, then it's better to work individually just by consuming initial endowment, right? Just by consuming initial endowment, the player one's utility level is going to be this one, given by this indifference curve. But indifference curve passing through this allocation will be lower than this one. So in such a case, player one, so consumer one, will not be involved in the correlation. Okay, so that is not the core. Similarly, for the same reason, this is not the core either. Now, player 2 will not be involved in the correlation. So the payoff allocation must yield higher utility than these two indifference curves, right? So here, this is a allocation. So this is the best allocations for these two consumers when they trade efficiently, because these are the allocation on the Pareto set. So every allocation is parity efficient in this set. So in this case, core is equivalent to the contract curve. Just the in case of two consumers. Okay, but in case of more than two consumers, now core will be subset of contract curve. Because the contract curve is just examines just a correlation consisting of one individual, like in this example, right? Because a contract curve is defined as the portion of Pareto set, uh, between the indifference curves. So it just examines a one individual correlation, but core considers all possible correlations. So core will be subset of the contract curve. One more thing you can notice is, because Wallace equilibrium allocation is will belong to the contract curve. So Wallace equilibrium is a subset of the core. Oh, so I'm gonna show this. I'm gonna show this one later. Okay, so let me just highlight the relationship between core and contract curve here. Okay, so in case of two players, they are equivalent, but in case of more than two players, core is a subset of contract curve. All right. So the previous figure reminds us the first welfare theorem that Wallace equilibrium allocation belongs to the contract curve because the Wallace equilibrium is a parity efficient according to the first welfare theorem. So it is on the contract curve. So therefore it has the core property. So now we are going to generalize this one. Okay, so in case of two players, because core is the same as the contract curve, right? So the Wallace equilibrium allocation must be an element of the core, must be element of the contract curve. So it should be on this line. So it has the core property. But in case of many players, more than two players, so more than two consumers, this insight can be generalized. So now we can prove that any Wallacean equilibrium allocation has the core property. So as a matter of fact, Wallacean equilibrium allocation is a subset of the core. Okay? Subset of the core. So the proof is pretty much analogous to the proof of the first derivative theorem. So where we show that Wallacean equilibrium is parity efficient. So that is a proof by contradiction. We first negate the conclusion of this proposition. So suppose to the contrary that Wallacean equilibrium allocation X star is not the core, so it's not an element of the core, so does not have the core property, so does not belong to the core. That means, okay, so does not have the core property, so it means there is a correlation S that block the equilibrium allocation, right? So now there exists a correlation. There we can construct a correlation S and another allocation X tilde. So this correlation S can improve upon or can block the equilibrium allocation X star. That means every member in that coalition weakly or strictly prefer allocation X tilde to X star, equilibrium allocation. Okay? Then, we maintain the assumption that preference relation is strictly convex and strongly monotone. Strongly monotone. Right? So, using that assumption, because every good is desirable. So, if we think about a price, equilibrium price factor, it should be strictly positive. Right? Because every good is desirable. Because every preference relation is strongly monotone, so the more, the strictly better. So price of any good should be strictly positive. Okay? So suppose that given this price factor, X star is the equilibrium allocation. So each consumer chooses optimally allocate a bundle X. That means if X tilde was better than X star, okay, then by the revealed preference, this X tilde was not affordable under price vector P star. So we can write P star dot Xi tilde. So that is a strictly larger than P star dot X star I. Okay. Otherwise, consumer I would have chosen this X tilde instead of X star. That is a contradiction with equilibrium allocation. Because equilibrium allocation must maximize consumer I's utility, right? And then we know that this P star dot X star is on the budget set. So P star dot his endowment. That's the market value of his endowment, right? And this is true for every member I inside the coalition. And then, we have a one strict inequality for at least one consumer, because at least one preference relation is a strict. So if we do if we do sum over I inside the coalition, so summation over I, summation over I, summation over I, okay? Then we have, this one is, so this one is, okay, so this one is larger than this one. And then remember, P star is, so we can rewrite this. So let me first rewrite this, because P star is a, strictly positive vector dot summation of X tilde is larger than P star dot sum of omega I inside the coalition, okay? And because P star is a strictly larger than zero, null vector, so we conclude that X tilde, summation of X tilde inside the coalition is larger than this guy. So meaning that this X tilde is infeasible. It does not satisfy the second feasibility condition. So there is no such allocation that there is a no feasible allocation X tilde inside the coalition. Inside any coalition, every member in that coalition strictly or weakly prefer X tilde to X. Okay, so that is a proof of this proposition 4.1. Okay, so the previous Edgeworth box diagram shows that. So you know what? So that reveals any Wallachian equilibrium allocation has the core property, just in case of two consumers. But at the same time, there is only one equilibrium allocation. So the other allocations in the core, say this one, this is not an equilibrium allocation because there is a no equilibrium price factor supporting this one as an equilibrium, right? So if we connect these two, say like this, with a omega, then you can easily check that with this price factor, indifference curve tangent to this price factor are not equal to each other. MRS are not equal to each other, right? So this is not a equilibrium allocation. So the only equilibrium allocation is going to be this one. Okay, so from this figure, it is evident that the converse of the previous proposition. So the core, every allocation in the core is a Wallachian equilibrium. That is not true. Okay, so core C is in general a larger set than the set of Wallachian equilibrium. Okay, so we have this one. C, so Wallachian equilibrium is a strict subset, I guess. So not equal to C, okay, is a proper subset. Yeah, proper subset of core. Okay. But now what Edgeworth conjectured is, now we increase the number of consumers. So as number of consumers goes to infinity, the state of a core converges to Wallachian equilibrium. All right. So let me stop the first video here because I already spent 1 hour, and let me make another video about this last topic to complete the so to illustrate the other remaining topics. All right.